All right, in this example here, we're going to take the integral of the following expression here. We have 2 plus the third root of x over the sixth root of x plus the third root of x plus the square root of x, all with respect to dx here. So right away, we're going to want to do a substitution on this. I'm going to let t equal the sixth root of x. So in other words, t is x to the power of 1/6. And we want to get rid of all these cube roots and sixth roots and square roots and write this with respect to t. So I can go ahead and do that. If I square both sides here, I'm going to get t squared is x to the third, which is my third root of x. If I raise this to the power of 3, I'm going to get x to the power of 1/2, which is my square root of x. So I know I can replace the cube root of x with t squared. I can replace the square root of x with t cubed, and the sixth root of x will be t. So that takes care of a lot of these here. I also have to change my with respect to, put that with respect to t now. So if t equals the sixth root of x, therefore dt is going to be 1/6 x to the negative 5/6 dx, and therefore dt is 1/6 times, I want to get rid of x here, so therefore t to the power of 6 is going to be equal to x. So I can replace this x with a t to the power of 6, and that'll all be to the negative 5/6 dx. Therefore, we have dt is going to equal 1/6 t to the negative 5 dx. Multiply across by t to the 5, I'm going to get t to the 5 dt equals 1/6 dx. And finishing this off here, I know that 6 t to the 5 dt is equal to dx. So I can get rid of this dx and replace it with a 6t to the power of 5 of dt. So let's take a look at our new integral here. This will be the integral of 2 plus the third root of x, we found out to be t squared. I'm now replacing dx with 6t to the 5 dt, and then replacing the sixth root of x with t, the cube root of x with t squared, and the square root of x with t cubed. So now we're looking at the following expression here. Let's go ahead and continue this. So now I have the integral of 12t to the 5th plus 6t to the 7th with respect to t, and this whole thing is over t plus t squared plus t cubed. So right away here, I'm going to go ahead and factor a 6 out of this expression. And you'll notice here I have a common factor of t. I can reduce this to become, so this will be 2t to the 4th plus t to the 6th with respect to t all over. I can rewrite this as t squared plus t plus 1. So again, I had a common factor of t in the numerator and denominator, so I factored that out, canceled it off, and factored a 6 out as well. So now I'm here. I'm going to break this up into two separate integrals. This will be 6 times the integral of 2t to the 4th over t squared plus t plus 1, again with respect to t, plus the integral, again that 6 in front, don't forget, t to the 6 over t squared plus t plus 1 dt. All right, so we're going to take care of these individually. I'm going to go ahead and tackle this first, and then separately we can take a look at this one. Add them together, we should get our answer here. So take a look at this first one here. We're going to have to use long division here and break this up, make the integral much easier. So I'm going to move that 2 out in front. So I'm going to go ahead and take this expression, move that 2 out in front. I'll change that to a 12. And we'll focus on this expression right here. Just fix that t. So I'll go ahead and do long division. This will be t squared plus t plus 1, and dividing into t to the power of 4. So this will be a t squared here. And going through our long division, I get t to the 4th plus t cubed plus t squared. Subtracting it up, I get minus t cubed minus t squared. And then we're going to continue this here. This will be a minus t, giving me negative t cubed minus t squared minus t. Subtracting up, I get t. And then you'll see that we are now done here. So putting this together, I now know that t to the power of 4 is going to equal t squared minus t times t squared plus t plus 1 plus t here. So therefore, t to the power of 4 over t squared plus t plus 1 is going to be t squared minus t plus t over t squared plus t plus 1. So using our division of long division of polynomials here, I can rewrite this as follows. This will allow me to go ahead and take the integral. So let's take a look at that expression here. And you can see here I've now replaced my t to the power of 4 over t squared plus t plus 1 with the following expression. I let the integral sign act linearly on it so we can kind of tackle these individually. Makes taking my integral much easier. So this will end up being, okay, so now that I have this broken down here, I still want to assess this integral rate here. I'm going to wait and see if you get any sort of like terms in the second expression. Let's go ahead and do the exact same thing to this integral here. We're going to go ahead and go through our long division. Okay, so continuing this up here, I got to break down this rational function. I'm going to go ahead and do long division on this again. So I'm going to take our polynomial. I'm going to divide that into t to the power 6. So this will be t to the power 4, which gives me t to the 6 plus t to the 5th plus t to the 4. We subtract that up. I get negative t to the 5th minus t to the 4th. And then I'm going to go ahead and subtract that from t to the power of 3, giving me negative t to the 5th minus t to the 4th minus t cubed. Subtracting that up here, everything cancels. I just end up getting a t cubed here. So now I'm going to have to go ahead and add a t, which will give me t cubed plus t squared plus t. And subtracting this up, I'm going to get negative t squared minus t. And we have one more operation here. I have to go ahead and subtract off a 1, thereby giving me minus t squared minus t minus 1. And subtracting this up, I get 1 left over here. So therefore, we know that t to the power of 6 can be expressed as t squared plus t plus 1 times t to the 4th minus t squared plus t minus 1 plus 1. So therefore, t to the 6 over t squared plus t plus 1 is going to be this expression here, plus 1 over t squared plus t plus 1. So therefore, we can write this our integral here as 6 times the integral of t to the 4th minus t cubed plus t minus 1 plus 6 times the integral of dt over t squared plus t plus 1. And again, this chunk here should be with respect to t. So now I want to combine these two together. I still have my integral to take here. Let's go ahead and do that before I combine these together. So this is going to end up being, also this one here, there should have been a 12 in front here. So let's go ahead and add that 12 from before. This is going to equal 12. And this whole thing is being multiplied by 12. So continuing this on here, this will be 6. I'm going to take my integral here. So this will be t to the 5th over 5 minus t to the 4th over 4 plus t squared over 2 minus t. That'll be the integral of that. And I'm going to leave this as it is. So let's combine these two together. There should be some common terms and fractions here. So let's go ahead and do that. So I get the following. I'm going to go ahead and distribute this. This is going to be 4t cubed minus 6t squared plus 12 times the integral of t dt over t squared plus t plus 1 plus 6/5 t to the 5th minus 3/2 t to the 4th plus 3t squared minus 6t plus 6 times the integral of dt over, notice it's the same denominator that I have over here. These are the same. So I can put these together and start collecting some like terms here. So I don't know if I have any like terms. If I take a look at 4t cubed, I do not have any other t cubed, so that's on its own. I have a minus 6t squared I can combine with 3t squared. I also have a, that would be it. So putting this together here, this is going to be, and I'll go by order of degree, this is 6/5 t to the 5th minus 3/2 t to the 4th plus 4t cubed. Combining those t squareds together becomes minus 3t squared minus 6t plus the integral of 12t plus 6 over t squared plus t plus 1. And again, that's with respect to dt. So finishing this off here, we get expression from before. This is going to end up being here. I can factor the 6 out, and I'm taking the integral of 2t plus 1 over t squared plus t plus 1 dt, and that'll be equal to the ln. So we got 6/5 t to the 5th minus 3/2 t to the 4th plus 4t cubed minus 3t squared minus 6t plus 6. This will end up being the ln of t squared plus t plus 1. Now, when I go to take my derivative of this, just to check to make sure they line up, I end up getting the derivative of this is going to be 1 over our t squared plus t plus 1, and the derivative of the inside is going to be 2t plus 1, which is exactly what we have. So I can go ahead and add my constant value k. So if you remember, long ago we did a substitution. We let t equal all the way back here. This was a monster question. T was the 6th root of x. So I'm going to sub that in here. So this is all the 6th root of x. This is going to be 6/5 x to the 5/6 minus 3/2 x to the 4/6, which will be 2/3, minus 3. This will be x, and it's to the power of a 6. This will be to the 3rd, minus 6 x to the power of a 6, plus 6 ln of x to the 3rd plus x to the 6 plus 1 plus k. All right, so there you go. That was a challenging problem, lots of algebra to keep track of here, and we end up getting the following integral. And quite a long question here. In case you forgot what the original question was, we were looking to take the integral of the following expression here. If you've got a better solution, feel free to send it to me. Thank you.